We will now begin reinforced concrete beam design. Go to Building Analysis, Pre-Analysis tab. Click Edit Materials. Click on Grade 500 next to Concrete Beams. Click Edit, next to the rebar diameter. These are the master settings for rebar's diameters to be used in the design. For beam design, review the main rebars to be used in the design and the shear links. Click Cancel. Cancel again. Cancel again. Then click Close to exit the Building Analysis dialog. Go to Design tab, where various design functions are available. Design all. This is a very quick way to design the members. However, it doesn't show any useful information of individual beam pass and failure. Hence, it is not recommended if this is the first round of design. It is useful if you have already designed the members before and due to amendments, you want a quick redesign or recheck. Cancel to exit. Click Story Beam Design. Maximize the dialog for a better view. The main beam design page lists all the beams design according to its insertion axis. Beams that are modeling using the same longitudinal axis will automatically be designed as continuous if they are connected. Further, beams that are inserted sharing the same insertion axis will also be merged together as a single design axis. For example, B1, B2, B3, the curve beam, B20 and B21 are all automatically merged as a single design axis, A. The design status is now all red cross, indicating design is not performed yet. Further, the utilization ratio is 0. This means that all the beams have no prior design done. Before designing the beams, we should review the design settings. Go on Settings and Parameters. This will launch the Settings Center with Beam Design Settings expanded. We will only go through the important settings. You can read more details in the Prota Help Center website. Design shows the main design considerations. Ignorable forces are forces that the beam design does not check nor design, hence user can define their own limits. If actual design force is equal or less than the ignorable limits, the beam passes, else the beam fails. Parameters. Choose the minimum and maximum main, hanger, and link rebar sizes. Concrete cover settings. A value of 0 means default to code requirement. Steel bar properties contains minimum and maximum rebar spacing setting. Steel bar cut length affects lapping. Web steel are side or laser bars. There is an option to ignore code-based minimum clear bar spacing, which can be activated in situations where special admixture or superplasticizers is used. Link properties. Review minimum and maximum link spacing. Rebar patterns. This lists down the various rebar patterns that can be used in the beam design. For example, let's look at standard pattern 2, which is commonly used for cast in situ concrete. There is summary description of this rebar pattern and number of rebar types and layers. Under rebar types list the different position of the bars. Each bar has its own curtailment options. For example, select top bar. This is the topmost layer bar that covers the top span and top support region of the beam and is by default set at layer 1. You can zoom in the diagram and locate its position in the beam diagram. Each rebar is also plotted separately below the beam diagram. The default extension is short of the column, which can be changed by clicking on the drop-down menu. Support top bar 1 and 2 covers only top support region. Bottom bars 1 and 2 refers to the bottom span bars. Support bottom bar covers only the bottom support region. Web bars are the side or laser bars. Multi-layer patterns allow more layer of bars and can be used for deeper beams. Example multi-layer pattern 4 allows 5 layers of top bar. Ensure standard pattern 2 is selected and then click set pattern as default so it will be used in auto design of beams. At the bottom beam type, there is a choice to set different pattern for floor, ribbed and foundation beams. Next, the option to show diagrams of 1, 2 or 3 spans. The default pattern selected is shown next. Steel bar selection. Method. Display steel bar spacing during design will list down all the bar spacing failures in the message report after batch design. Include bar spacing checks to design status. If checked, will ensure minimum and maximum bar spacing requirements are met. If requirements are not met, then the beam design status will be marked as failed. If this option is unchecked, even if bar spacing or requirements are not met, it will not be flagged as failed, provided that all other design requirement, such as required steel, passes. Rebar spacing optimization method will maximize the distance between the bars by increasing the rebar sizes during design. Rebar diameter minimization method will minimize the spacing between bars by minimizing the size of the rebars during design. Steel bar area tolerance. -% tolerance values will yield greater steel areas than required. Positive value means you want to use less steel than required. Minimum top steel at pin. Enforces a minimum percentage of steel at the pin or hinged end as percentage of span required steel area. 25% is specified in Eurocode and hence adopted here. Select same bar diameter for all beams on the axis. Check to force same bar diameter for top, bottom or hanger bar layer. Second layer steel settings offers option for same bar size and/or same number bars in first and second layer rebar. Height-width ratio limit for multi-layer pattern will be used to determine the beams to be included in Optimize Rebar Layers function in the beam design menu. Only beams equal and exceeding this ratio will be included in the optimization process and auto-assign the multi-layer bar pattern. Bent-up bars. These are only used when a bent-up bar pattern is selected. Links. Review the link's design and selection settings, such as minimum support region width. Refer to the diagram for guidance. Curtailment. Steel bars. Bottom span bars controls the position of lapping of bottom bars. Refer to the diagram below when changing options. Top support bars settings. Similarly, refer to the diagram below for illustration.
Rebar extensions lengths is set here. Refer to the diagram below for explanations.
Steel bars too affect the end span curtailment of bars. Check and uncheck options and see the difference in detailing in the diagram below. Bob control. BOB stands for bending of bars. The settings here controls the length and pattern of bending of bars. Detail drawings. All the settings in this group affect the general arrangement drawings and details generated in Prota Details. It does not affect the design of the beams at all. General tab. Affects all type of drawings. Beams. These settings only affects the beam elevation drawings. Sections. These settings control the sections cuts and presentation of the beam elevation drawings. Steel bar and links. These settings controls how rebars and links are drawn and annotated. For example, there is an option to display BOB as shifted. Check this and refer to the diagram for illustration. Sidebars are laser bars detailing of deeper beams in elevation drawings. Dimension settings controls all dimension presentation of beam elevation drawings. Detailing tab affects drawing production when Prota Details. This are miscellaneous settings affecting the beam details, example how it is arranged and truncated if inserted into sheets. Click OK to save and exit. To design all the beam at one go, choose Beam Design, Batch Mode. In the batch design, there are three options. Check steel, select new steel when previous bars are insufficient. This option is only applicable if a previous design was done. This option will check if the existing reinforcement is sufficient and only increase the reinforcement at location where it is not sufficient. At location where is sufficient, even if over-designed, will be left unchanged. Check steel, don't select steel when previous bars are insufficient. This option is only applicable if a previous design was done. This option will check if the existing reinforcement is sufficient and will not increase the reinforcement even if it is insufficient. Failed beam axis will be marked accordingly with a red cross. Reselect all bars. This option will completely redesign all beams using the current beam design settings. This basically ignores all previous design. Since this is the first time designing beams, choose Reselect all bars. Click Calculate. The batch design will start. When the design is completed, the message icon will appear. It is very important to display the message as it contains vital information about pass and failure reason. If the design is successful, a default text listing the axes will be shown and the design passes. If there are failures, the exact reasons will be stated and the design status will be shown as fail. Close the message report. Close the beam batch design dialog. The design screen will be refreshed now to show the design status and the utilization ratio. The beams to be included in the report are marked by a tick in the print column. Only beams that are successfully designed can be marked for printing. Beams can be added or removed from the report by checking or unchecking the print check box. Click Remove Print Marks to remove all the print marking. Then mark only beam axis A for printing.
Click Summary Report.
In the reports dialog, there are further choices which are self-explanatory.
Print beam loads. This will print out detail loadings on the beam such as slab decomposed loads, brick wall loading, and manual loads. For a more concise report and faster generation, we can uncheck this option. Click OK.
The beam design report will be generated. Key design parameters, results and rebars will be included. All reports can be exported as PDF, Microsoft Word, image or web page, HTML format. Inspect the report. Close the report. All reports generated will automatically be saved and made available for compilation in Report Manager later.
Detail report will produce a detail clause by clause report. Uncheck print beam loads for speedy generation. Click OK. The detail report will show a detail step-by-step check according to code clauses for each beam and each support and span section. Inspect the report. Close it.
Summary table report. This creates the report on summary of pass and failure of the beam, exactly as you see in this dialog. Flange shear check. This report checks the flange beam shear. Bar list report. This report lists down all the design rebars of the beams. Utilization ratio table. This report produces details on utilization ratios, that is, area required divided by area provided, calculated at each position of the beam. The largest utilization ratio is finally reported in the main summary dialog.